Assalamu alaikum, dear students. In today's class, we will discuss about the value of universal gas constant in two different units. First of all, we know the ideal gas equation is PV equal to nRT. This is what we call ideal gas equation. And from here, you can find the value of R. So R becomes PV divided by N times T. I took N times T on the other side, okay? So using this equation, I can find out the value of R, which is basically universal gas constant or molar gas constant, in two different ways, okay? So first of all, in SI unit, which is the international unit, if you want to calculate R, you have P and then V divided by N times T. Remember, guys, the way we calculate the value of the pressure is by using a thermometer, which is by using a thermometer, a barometer, not thermometer, a barometer. And inside the barometer, there is mercury, right? And mercury is basically in liquid state. It's in liquid state. So, if you want to calculate the pressure inside a liquid, you have to use P equal to H rho G. Let me clarify. So in order to calculate the pressure, you need mercury tube. And if you want to calculate the pressure, you have to use H rho G. So pressure is calculated using H rho G. And there is this V, which is the volume of the gas, divided by N times T. Let me remove all of this. Let me clean the board first, okay? Okay, dear students, now what is the value of H? So R, remember, this is the universal constant. So we have already defined that in order to calculate pressure, my H value should be 76 centimeters, which is 0.67 meters, right? So I put 0.67 meters times, and then rho is nothing but 13,600 kg per meter cube, okay? And then I have G, which is 9.8 meter per second squared. So then I have this volume of the gas of an ideal gas, where the temperature and pressure is taken, is the ideal temperature and pressure. In that case, the volume of all the gases becomes 22.4 liters. Okay, so I don't have the space here. I want to actually, I will remove all of this. I will rewrite all of this here. So I have 0.76 meters times 13,600 kg per meter cube times G is 9.8. And now the volume is 22.4 liter, but this is the SI unit. So you have to convert that into meter cube. If you want to convert liter into meter cube, you have to multiply by 10 to the power minus 3. So now the volume is 22.4 times 10 to the power minus 3 meter cube. Okay, I have everything I need here, divided by this N times T. Okay, so N times T, which is basically N is the mole number, and in the standard case, in order to find out the value of R, we take N equal to 1 mole always. Okay, T is the temperature. This is the standard temperature. So this is the standard temperature, and we know standard temperature is nothing but 273 Kelvin. Okay, 273 Kelvin. Now you use a calculator to find out all the values. So let me put all of this in a calculator. 0.76 times 13,600 times 9.8 times 22.4 times 10 to the power minus 3 divided by 273. So the value is 8.31. So the value of R in SI unit is 8.31 joule per Kelvin per mole. Now if you want to ask, let me clarify before you asking that how did I find out the unit joule per Kelvin per mole? Because Here R is equal to PV divided by NT. Remember, P is the pressure and the unit of pressure in SI unit is Newton per meter squared and the volume is meter cubed. You can see that here too, right? N is mole, and this temperature is basically Kelvin. So if you multiply, you have Newton, and then if you multiply these two, you get meter, and then Kelvin will be Kelvin inverse. If I take Kelvin from the denominator to the numerator, I have to put Kelvin inverse, and similarly this will be mole inverse. And you know that Newton meter is nothing but joule. Newton meter is nothing but joule. So this becomes joule per Kelvin per mole. This is how I find out the value of, the unit of R. So I hope you understand this. Now we will go into the other one, which is the liter atmosphere unit. Okay, let's go for liter atmosphere unit. Okay. So now my R is PV divided by NT. That is from this equation. In the liter ATM unit, what you do is that you put the pressure is equal to 1 ATM. Pressure here is 1 ATM. In the SI unit case, you have to find out that in Newton meter squared, right? In Pascal. And the volume is 22.4 liter. But in the SI unit case, you have to convert that into meter cube. And my N, which is the mole number, is basically 1 mole, and my temperature, which is basically 273 Kelvin, right? So if I take all this calculation, let me do it for you, right? If I do all this calculation, I have 22.4 divided by 273, and I have 0.082, and the unit is liter ATM per Kelvin per mole. You know how? Because see, liter and then times ATM, and then if I take it to the numerator, I get Kelvin inverse, and this will be mole inverse. So this is the liter ATM unit. So R is found out in liter ATM unit. So I hope you understood how to calculate the universal gas constant now. Subscribe to my channel for more videos like that. See you in the next video.